Okay, suppose we have acid. I am taking hydrochloric acid here. When hydrochloric acid dissolve in water, okay, so it will undergo dissociation to form H positive ion and Cl negative ion beta. Okay, understood?
So can you repeat once again?
See, I have taken HCl, or we can take H2SO4, sulfuric acid, H2SO4. You know, na, sulfuric acid. If we will dissolve in water, acid or any substance when dissolved in water will give us H positive ion along with HSO3 negative ion. Okay, so see both the compound when dissolved in water, okay, they gives H positive ion here. Is it or not?
Yes, sir.
So any substance when dissolved in water produces H positive ion are called as acids. Are called as acids. Understood?
Yes, sir.
Like probably in 8th class, 9th class, you must be like gone through the definition. Those substances they are sour to taste. Okay, are called as acid. Yes, they are sour to taste, but they produces H positive ion when they dissolve in water. Okay, so H positive ions means what now? What is H positive ion? See, we know hydrogen is the element having only proton in its nucleus and not neutron, right?
Yes, sir.
Yes. So only hydrogen is the atom have no neutron in its nucleus and its atomic number is 1. Number 1. So here we have 1 proton and here we have 1 electron. So it is the structure of hydrogen atom, right?
Yes, sir.
Okay. So if we will lose that electron from hydrogen, so hydrogen when loses electron to form H positive ion. So at H positive ion state, only one proton is present at the center of atom called nucleus. Only proton will present because that electron is going to lost by hydrogen. Is it or not?
Yes, sir.
That means H positive is nothing but one proton. So can we consider as H positive ion is equals to proton?
Yes, sir, we can.
Yes, because at H positive ion state, hydrogen do not have neutron and electron also. So it can be considered as proton. Okay, now, so we can say those substance when they dissolve in water and they use H positive ion, that means protons. So can we say acids are proton donor because they are donating proton here. Acids are
Yes, sir, we
proton
can.
donor. Yes, proton donor. Okay. If we will represent the reaction at equilibrium, okay, so I have taken here HCl, okay, when the saturated solution will form. After that, if so here we have H positive ion plus Cl negative ion. So when number of like HCl will undergo dissociation, same time, okay, H positive and Cl again going to combine to form HCl, hydrochloric acid. So if, okay, when suppose during the dissociation we have kept the temperature constant, we have kept the temperature constant, and after some time what will happen when saturated solution will form? So one time will come when suppose one molecule of HCl going to break down to form H positive and Cl negative ion. Simultaneously, same time, one H positive and one Cl negative will attract each other to form H positive, HCl. So see, same time the reaction proceed in this direction also and in this direction also. So this state is called a beta equilibrium. This state is called as equilibrium, and it is possible only when there is a temperature is constant. When there is a temperature is constant. Okay.
Yes, sir.
So at a given temperature, okay, the product of the concentration of the reactant, okay, the product of concentration of the reactants of the reaction product raised to respective stoichiometric coefficient is the balanced chemical equation divided by product concentration. So concentration of product of concentration of reactant divided by product of concentration of product. See, the product of concentration of the reaction, okay, the product raised to respective stoichiometric coefficient in the balanced chemical reaction, which is divided by the concentration of product, okay, of the reactant raised to their individual stoichiometric coefficient has the constant value. This is known as equilibrium law or chemical equilibrium. It is also called as chemical equilibrium. Okay, beta?
Yes, sir.
Okay. So what is homogeneous equilibrium? See, what is meaning of homogeneous? Yes.
Sir, something like similar.
Yes. Suppose I am taking a glass of water here. Okay. Suppose that much we have water here. And if you are going to dissolve NaCl here, NaCl means sodium chloride. So one sodium chloride, suppose 1 teaspoon of sodium chloride you have took here and you just dissolve that. So can you, after dissolving, can you find where the NaCl particles are in solution? Can you do that?
Sir, what were you telling?
Suppose you have taken water here. Okay. Suppose this is a transparent glass jar. You have taken water here. Suppose 1 liter of water. 1 liter of water. And you are taking 1 teaspoon of sodium chloride, the salt that we are using in our daily diet. And you are dissolving that salt in water. So after dissolution, can you identify where the NaCl and where the water molecules are there in solution?
No, sir, no.
That means here, see, sodium chloride is present in small amount, a small proportion, so it is called a bit of solute. It is called as solute. And water is present in large proportion, hence it is called as solvent. It is called as solvent. So when solute and solvent are present at the same phase, okay, same phase means you cannot identify them, means it is the same phase, okay, that say when they are present in same phase, then it is called a bit of homogeneous. It is called as homogeneous. In stainless steel, the utensil that you are using at your home, stainless steel objects, okay, okay, so can you see what is stainless steel? It is the alloy of ferrous and carbon. Ferrous and carbon. So are you able to identify carbon atom and ferrous atom in the solution or the homogeneous mixture on steel? No, na?
No, sir, no.
Yes. So can we say steel is again homogeneous?
No, sir.
Yes, beta, we can, because you cannot identify carbon and ferrous separately, no? So it is again homogeneous. Okay?
Okay, sir. Okay.
Yes. Okay. Now, next. So the equilibrium in which all the substances are present at the same phase. Same phase means you cannot identify them separately. Means they are same phase. Okay. If equilibrium in which the substance may be a reactant or product present in the same phase, then it is known as homogeneous equilibrium. It is called beta homogeneous equilibrium. So if we will see here, we have nitrogen gas reacts with hydrogen gas to form ammonia. Okay, so all these are present in the same phase. You cannot identify whether the black gas, white gas, yellow gas, like this. Okay, all the gases will be at like same phase. You cannot identify in a solution like nitrogen, hydrogen and ammonia separately. Okay.
Okay, sir.
In second example also, here we have ethanoic acid. It is also called as acetic acid. When reacts with ethanol, here we have acid and it is alcohol or ethanol. Okay, so we know that when acid reacts with alcohol gives ester beta ester. So this is called as ester and its name is ethoxyethanoate. Its name is ethoxyethanoate. Niyati just came in the class. It is called beta ethoxyethanoate. It is called as ester. So this is the esterification reaction where carboxylic acid reacts with alcohol or ethyl alcohol gives ester. So here that ester, water, ethanol and carboxylic acid again present in the same phase only. Same phase only. Again it is the example of homogeneous equilibrium. Okay.
Okay, sir.
Now next we have heterogeneous equilibrium. So first we have to understand what is heterogeneous. Suppose you make you used to buy most of the product like vegetables in a one bag only. Okay, suppose this is the shopping bag you are having. Okay, here you are buying potatoes here, brinjals here. Okay, then carrot here only, like this. Okay, so you can identify onion also here, so you can identify separately in that particular shopping bag, right? So when substance can be observed separately in their mixture are called as heterogeneous solution. Okay, understood?
Okay, sir. Yes, I
Yeah.
understood.
So now we are going to understand homogeneous equilibrium. So when equilibrium acquires, okay, in which substance involved are present in different phase. Different phase means you can identify them separately. Suppose this is the tea, no, sugar, uh, sugar box at your home, sugar, a sugar container. It is the sugar container. But Devanshika used to eat sugar every day, like behind mom. Okay, so mom is got like angry on Devanshika that she used to eat sugar again and again. So it may be cause, it may be harm. So what Devanshika's mom is doing, she used to add tea here, tea leaf. Okay, so now here along with the sugar we have tea also. Okay, so now Devanshi is going to eat. Suppose when Devanshi will open that container's cork, so Devanshi will observe here sugar particles as well as tea particles. So then Devanshika is not going to eat that sugar, right? Because she can observe sugar and tea separately here. Is it or not?
Yes, sir.
So that mixture of tea leaf and sugar will be the heterogeneous mixture. So the equilibrium in which substance involved are present in different phase are called as heterogeneous or is called as heterogeneous equilibrium. So here we have calcium carbonate which is present in solid, then calcium oxide will also present in solid, okay, and carbon dioxide will present in gaseous form. So all this will be present in different form, a different phase. Calcium carbonate will look different, okay, will look different than calcium oxide will again different. In case of water also we have liquid water separate and we have steam separate. Is it or not? So they can be observed separately. So they are, if we can observe them separately, that means it is the heterogeneous equilibrium. And whenever we are using the word equilibrium, we are representing that symbol reversing. Okay, so in at that particular stage the rate of forward reaction is equals to rate of backward reaction. That state is called beta equilibrium. Okay, what is equilibrium? When the rate of forward reaction, forward means any reaction which proceeds from reactant to product is called as forward reaction. But when reaction proceeds from product to reactant, then it is called as backward reaction. Okay, so it is the state at a constant temperature when the rate of forward reaction becomes equals to the rate of backward reaction is called as chemical equilibrium. It's called as chemical equilibrium. Understood?
Yes, sir. Understood.
Okay. Mhm. So define equilibrium constant. Okay, so now we are going to understand about the equilibrium constant. So equilibrium constant is nothing but the ratio of product of molar concentration of the product to product of molar concentration of the reactant at a given temperature. See, temperature will be the constant. We can calculate at 20 degrees Celsius. We can calculate at 25 degrees Celsius. Okay. But if we are discussing about 25, so that must be for reactant and product, they must be present at 25 degrees Celsius only. Okay. Yeah.
Okay, sir.
So the ratio of, see, ratio means the division. Okay, so ratio of product of molar concentration of product. Molar concentration of product means suppose we have any reaction, I'm just taking A, when it reacts with B to form C and D. So here we have A and B are reactants. Is it? And C and D are the product. Is it or not?
Yes, sir.
Yes. So the mole, see, it says the molar concentration of product. Molar concentration means in order to represent the concentration, we are using square bracket like this. Okay. So their product, so we have concentration of C into concentration of D, divide by concentration of A to the into concentration of B. So their ratio is called as beta equilibrium constant. Equilibrium constant. Understood what is equilibrium constant now?
Yes, sir. Understood.
So just do remember that reaction I have written over here. The concentration of product to ratio, the ratio form divided by concentration of reactant. That's all. It is represents by beta Kp. K is the constant. Okay. So write the relation between Kp and Kc. See, but if whenever we are writing del n is also always represents the change in number of moles of gas, or number of moles of any product, maybe gaseous, solid or liquid. Okay. Okay, beta.
Yes, sir.
Okay. Then we have, can catalyst disturb the rate of equilibrium? Yes. Catalyst are the substance we, no, it says no. If it is equilibrium, then no, it is not going to disturb. No, but equilibrium is attained quickly because the catalyst increase both the rate of forward reaction as well as backward reaction. That's why it has no effect. Okay, because whenever we are using catalyst, so it will promote or it will increase the rate of backward as well as forward, both the reaction. That's why there is no effect on catalyst on the equilibrium constant. So what is catalyst? Niyati, catalyst beta. Niyati, you there?
I'm there, sir. My connection is bad. We just had a power cut.
Okay. Devanshika, what is catalyst? Devanshika. Devanshika, you there?
Sir, can I tell?
Yes.
Sir, it like increases the rate of the reaction, but it doesn't get consumed.
Okay, yeah. So those substance they use to increase the rate of reaction, or their presence increases the rate of reaction, are called as catalyst. Okay, suppose we have just gone through the example. Suppose we have A when it converts into B. So here A we have reactant and B we have product. So if we will use catalyst here, so catalyst will increase the rate of forward reaction, that is the forward reaction, and also increase the rate of reverse reaction, means backward reaction. Backward reactions are also called as reverse reaction. Okay, so that means catalyst will have no effect on equilibrium constant, because after we will, whenever we will use catalyst, so catalyst will promote or increase the rate of both the reaction equally. That's why there is no effect of catalyst on the equilibrium constant. Next, what is the effect of temperature on systems at equilibrium? Okay, if we will increase the temperature, okay, or we will decrease the temperature, after some time equilibrium is going to acquire. Okay, so increase the temperature favors endothermic reaction. Okay, if we will increase the temperature, a reactant or product will absorb energy, that will be endothermic reaction. And decrease the temperature, if we will decrease the temperature, favors the exothermic reaction. So there is possibility to release heat energy during the reaction, hence it is exothermic. Understood? Understood, beta? Keep replying. Devanshika, Niyati, both of you there, beta?
Yes, sir.
Okay. So, sorry. So I was discussing about when temperature increases or decreases, they favors the endothermic and exothermic reaction. Okay. Next example we have for Bronsted base, very important. Okay, most of the time it has been asked. So we know that we just gone through initially, okay, the today itself, the substance which releases H positive ion are called as acid. Is it? Is it or not? Suppose we have taken HCl, beta, HCl. So it will like dissolve in water to form H positive ion and Cl negative ion. So can we say HCl releasing H positive ion? Can we? Keep replying. I am waiting for your response. Devanshika, Niyati.
So you're telling something?
Yes. Am I audible clearly or not?
Yes, sir, you're audible.
I'm saying that just do reply continuously whenever I'm asking the student.
Yes, sir.
Sir,
Actually, I went to drink water, sir. So
Okay.
sir,
So I
you're
was
audible. Sir, you're audible, but my connection is bad. I just had power
okay.
cut.
So
Sorry.
I was explaining about acids. So what are acids? We've already gone through that. Acids are the substance when they dissolve in water produces hydrogen ion or H positive ion. Okay. So just do think differently. If substance accept H positive ion are called as base. Okay. So those substance when they loses or donate H positive ion. Okay. If H positive ion is lost means H positive will get separated from the compound, then they are acids. Okay, when H positive ions are by gain, okay, by gain, so whenever the substance gains H positive ion are called as bases, beta bases. So you can see here ammonia when reacts with hydrochloric acid. So I'm writing the reaction over here. When ammonia, NH3 is ammonia gas, reacts with hydrogen chloride, HCl. Okay, gives NH4Cl. NH4Cl. It is ammonium chloride, beta. It is ammonium chloride. If ammonium chloride will dissolve in water, will gives us NH4 positive ion and Cl negative ion. So that NH4 positive ion has formed from NH3. Is it or not?
Yes, sir.
And here that when HCl will dissolve in water, so it will form H positive and Cl negative. So that H positive ion will attack on nitrogen, okay, to form NH4 positive ion. Okay.
Okay, sir.
Yeah. So in ammonium chloride, that ammonia accept hydrogen positive ion. That's why it is called as base. And that theory is given by Bronsted. That's why it is called as Bronsted base. Okay. So in above reaction, ammonia accept H positive ion means proton. Okay, from HCl. So NH3 is the Bronsted acid base. Okay, so just do remember the definition whenever the substance accepts H positive ion. Okay, that must be the base according to the Bronsted. Okay, everyone.
Okay, sir.
Okay. Now next we have the Levi's acid. Okay, so Levi's acid are nothing but the substance which can accept the pair of electron. Okay, those chemical species they accept the pair of electron. Okay, are called as Levi's acids. Okay, everyone.
Okay, sir.
Just do revise the definition up to 9, then we will move further. Okay, so here we have very small concept that you have to remember, beta. So all the Bronsted base are Levi's base. Explain. We have to explain that. See, Bronsted base means proton acceptor. So just do remember, bases are the proton acceptor and acids are the proton donor. Okay, we already gone through that. Is it or not? So Levi's base
Yes, sir.
is electron pair donor. Very important, huh? Levi's base means electron pair donor. In order to accept proton, Bronsted base must donate an electron. Is it or not? That's why Bronsted bases are acting as and they are nothing but the Levi's bases. Hence, all Bronsted base are Levi's bases. See here, we have ammonia having two lone pair of electron. What are lone pair of electron, beta? Any idea? Any idea? Lone pair of electron means what? Any idea? Lone pair means what? Lone pair means non-bonded electron. See, we know nitrogen have total 7 electrons. So its electronic configuration is 2 and 5. So in outermost shell, nitrogen have 5 electrons, 1, 2, 3, 4 and 5. So out of which, okay, these 3 electrons are being shared by hydrogen. Here hydrogen, and here hydrogen. So they are called as bond pair of electron because they are forming the bonds. But these 2 electrons of nitrogen, they are not forming bonds, so they are called as lone pair of electron. Lone pair of electron. Is it or not? So that nitrogen have capacity to donate all these 2 electrons to other chemical species. Okay. Hence, it is the electron donor. It is electron donor, but may accept H positive ion. May accept H positive ion. So here two conditions. It is accepting H positive ion, means it is the base, and it is donating electron pair, hence it is the Bronsted base. Bronsted base. So all the Bronsted base are acting as a Levi's base. Is it or not?
Yes, sir.
Yes. Now, next, we have all Levi's acids are not Bronsted acid. Now we have to understand that, and with reason also. So substance which accept electron. See, here nitrogen was donating. Now we are discussing about the accepting electron. Huh? So substance which accept electron pair are called as beta Levi's acid. Levi's acid. Example in BF3, it is boron trifluoride. Okay, here which can accept pair of electron. Hence here it is the Levi's acid because it accepts the pair of electron. That's why it is Levi's acid. Substance which donate proton to Bronsted base. Now here the concept. Substance which donate proton means H positive ion, are called as Bronsted base. We already gone through that before. Okay, like proton acceptor are acid and proton donor are the base. So HCl in HCl, okay. So example HCl, because when HCl will dissolve, it will produce H positive ion. Is it or not?
Yes, sir.
Yes. So HCl is accepting here. So HCl is acid, not the base. Through BF3 Levi's acid, it does not have any proton. Okay, yes. Here, see, in acid we have proton, but in BF3 do we have any proton? No. Do we have?
No, sir.
No, na? So we can't say that BF3 is the Levi's acid because it do not have any H positive ion or proton to donate. So it is acting as a Levi's Bronsted acid, a Bronsted base, but not the Levi's base. See, substance which accept electron pair are called as Levi's acid. And see, we are discussing about Levi's acid are not the Bronsted acid. Why? Because it do not have any H positive ion to donate. That's why it can act as a Levi's acid, but not the Bronsted acid. This is the reason for that. See, BF3, B means boron. Sorry, BF3 have capacity to accept electron pair. So it is acting as the acid. It is acting as the acid. But do BF3 have any H positive ion to loss? No. No, na? Or do it has? No.
No, sir. No.
No. So it cannot act as a Levi's acid. It can act as only the Bronsted acid. That's why it is given statement says Levi's acid are not all the Levi's acid are not the Bronsted acid, because all the Levi's acid or Bronsted acid do not have H positive ion to lose to act as a Levi's acid. This is the reason for that. So it is not a Bronsted base. It is not a base beta, it is acid. Okay. Hence, Levi's acid are not the Bronsted acid. Somewhere that notes having some fault also. Here again, it is not the base beta, it is acid. Okay, it is acid. Huh? Here also it is acid. Okay, so just do correct on your notebook also, if you are having the same. Okay.
Okay, sir.
Yeah. So any doubt beta here?
No, sir.
Okay. Next question we have, ice melts slowly at a high altitude. Explain why. Again, it is very important. It is due to the difference in pressure. Okay, wait a second. So ice has more volume than water. You know, the density of water is highest at 4 degrees Celsius. Any idea about that? Water have highest density at 4 degrees Celsius, and below 4 degrees Celsius, or above 4 degrees Celsius and below 4 degrees Celsius, density of water will increase. And we know that ice forms after 0 degrees Celsius or at 0 degrees Celsius and lower temperature. That means that ice will have higher volume than liquid water. That's why ice float on water. Is it?
Yes, sir.
Yes. So when pressure is increased, okay, when pressure will increase, it converts into water. You know, regulation process, regulation, REGELATION, regulation. What is regulation? Any idea? Regulation is the process in which, suppose this is the ice cube, when you apply the pressure here with the help of string or any other like object, so due to pressure, that surface of the water will get melt. Oh no, surface of the ice will get melt. So ice converts into liquid due to applying pressure. And when pressure is removed, liquid again turn back into ice. Okay, this process is called as beta regulation. This is called as regulation. So when pressure is decreased, the above reaction occurs slowly, since at a high altitude pressure is very low. Okay, that's why ice melts slowly at a high altitude. Their pressure is very low. That's why at low pressure ice will melt very slowly. If higher pressure will be there, then it will melt fast, quickly. But if pressure is less, well, at high altitude, the melting of ice slows down. Okay, this is the reason why ice melts slowly at a high altitude. Understood, beta? Because at surrounding pressure is becomes very low at a high altitude, due to which the process of melting decreases. Okay, because in regulation we know that when pressure is higher, okay, or pressure is applied on the ice, it start melting, and when pressure is removed, liquid converts into the ice back. That means it shows that at high pressure, if pressure is high, ice will melt fast. If pressure is low, then melting process will be low. Understood? And we know at high altitude pressure is low, that's why melting process slows down. Understood, beta?